Alright, good evening everyone. My name is Brandon and today is, I don't know if it's episode 5 or it's episode 6, but I train every day. One, try hack your room, one new scaler, always ethical, and by 30 I will be a professional hacker. So today I am actually going to be doing the buffer overflow room that I didn't complete. I have been researching buffer overflow extensively since my last video as I was very confused on the topic and I was not sure how to proceed or really how to. I didn't understand what a buffer overflow was. So I'm going to pull up my notes here just so maybe I can reiterate what I've learned. Maybe it'll help me out so I can understand how buffer overflows work. I'm just going to pull up the room while I do that. We're gonna try Gatekeeper. I don't know if I'm gonna try Gatekeeper today. I'm a little short on time, but if I do have time, I will run Gatekeeper 2. Or Gatekeeper, rather, and see if I can get into that. So let me just boot up the room while before I start discussing so I could save some time. I'm on my virtual machine, so I'm not going to be using the attack box. And that's the SSH credentials. Okay. While that loads up, I'm going to briefly explain what I've learned from, or what I've learned about buffer overflow. So, buffer overflow is when a program or process writes more data than the memory buffer can hold. And the extra data will overflow into the adjacent buffer and it'll overwrite that data. And the objective is to overwrite that data in some way where we could exploit that memory address, it seems like. Um, this appears to only happen in C and C++. It looks like there are built in protections with other programming languages such as Python and Java, Rust. Everything is protected. So I'm mainly gonna be seeing this in like the older, low level languages, C, C++. Let's see, any other notes I could bring up here? So obviously this involves violating program languages and overriding the bounds of the buffer to trigger additional actions. And this sends new instructions to the application, which works in our favor. Um, this is probably one of the most common weaknesses, and it's one of the most dangerous because of what it could do. Um, Here, let's begin with the room. I did go through a bit of it, but here, we're going to do Overflow 2. I'm going to make this slightly less big because this is huge for me, but I know it's easier to read on camera when it's bigger. I'm going to open up my terminal. I need to just set up my VPN. Sudo VPN. I'm going to access the. Okay. We're going to make a new. Make sure I could ping the virtual machine or at 10.201. Alright, and we're staged. Okay, so let's take a look at the instructions. So, buffer overflow is obviously quite complex, but it's fundamental that I understand it, as this could be a great foothold and leverage in the environments that I want to hack. So, for this example, let's look at Overflow 2. So first I need to actually SSH so I could access Overflow 2. So we're doing user 1 at 10.201.75.10 and the password is user1 password. I think I typed that wrong. User1 password. I think I typed that wrong again. User1 password. Alright, great. We're going to go over to Overflow 2 and let's take a look first. For this example, look inside and you'll notice the following is C code. Okay, so let's go over to func pointer.c and let's make this bigger. Let's take a look. Geez, how do I get this thing to stay on the screen? Always visible, maybe? Alright, So let's take a look. We got three includes. Sorry, I received the message. Void special. This is the special function. You did this, friend. Normal. This is the normal function. Why is this here? Okay, so we got three functions here, and this is where we figure out how to do the buffer overflow. So in the int main function, we have int argc, so the first argument, we got char. Okay, so these are adjacent to each other in memory. Volatile int new pointer equals normal. I'm still struggling a little bit with understanding this new pointer. I'm not quite sure what a pointer is. Let me figure out what a pointer is. What is a pointer in C? In C programming, a pointer is a variable that stores the memory address of another variable. This is storing the memory address of new pointer. And so this is the name of the variable, is new pointer. These parentheses, this part is the part that confuses me. Is it not accepting parameters? Is that why it's closed? This equals normal. And I think this is calling to this function, but from what I've learned, when you call a function, you also include the parentheses. So okay, let's keep it moving. Char buffer 14. So this is storing 14 into this buffer. Or no, this is an array. This is an array. So there's 14 characters in this buffer. Gets buffered, this is the part that can be manipulated, because when you call gets buffered, this is actually what causes the buffer overflow. And if it pulls too much, it'll overflow into the next memory address. And new pointer. So this is calling new pointer, which is this. This is the normal function. Okay, so it's running this unless if I do this and a buffer overflows, does it skip this and then does it try to run one of these? Okay. Okay. Alright, let's go back and take a look. Similar to the example above, data is read into a buffer using the gets function, okay? But the variable above the buffer is not a pointer to the function. But the variable above the buffer is not a pointer to the function. A pointer, like its name implies, is used to point to a memory location. And in this case, the memory location is that of the normal function. That makes sense. So it's the memory location of this. The stack is laid out similar to the example above, but this time you have to find a way of invoking the special function, maybe using the memory address of the function. Try invoking the special function in the program. Keep in mind that the architecture of this machine is a little endian. So this therefore means everything is backwards. If it's endian. So this rather than pretty sure it's backwards. So invoke the special function. I need a hint. I don't really know. Check the memory address of the function. I don't know how to check the memory address of the function. Let me pull ChatGPT into this so I can get a bit more understanding. How how do I go about this? Let's do this. ChatGPT. I have this code here. Can you help me understand how to execute a step by step? Explain the whole process. Because this is the only way I'm going to understand the buffer overflow. I I mean performing it would be ideal, but I'm kind of lacking something here. I just don't really understand how to do most of this. This is a try hack me room. Alright, let's see what we got here. New pointer is a pointer to the function is initialized to the point to normal, which makes sense. Buffer is a fixed size array of 14 bytes on the stack. Gets buffer reads an arbitrary length line from std in into buffer without bounds checking. This is the classic unsafe C function. After input, the program calls new pointer. Whatever function pointer value is stored there will be invoked. So the goal is to change this address. And since it's endian, it goes backwards. So it overflows into this address. Because buffer and new pointer are stored in the stack adjacent or near each other, writing more than 14 bytes into buffer can overwrite nearby stack data, potentially including the stored value of new pointer. That is the new. Let's see if now. Oh, brother. What your program is doing clear conceptual walkthrough. So I'm gonna just attempt to do an out of bounds request to see how I could get this to invoke. Segmentation fault. Okay. Maybe too far. Segmentation fault. What happens if I just do nothing? Okay. A. This is the normal function. Now, I'm guessing it's probably 15 and over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15? Okay, now I'm going to try 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Illegal instruction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are multiple legitimate ways to make the program without exploiting anything. I'll show the clean defensive options, no overflow or exploit. Just call it in main. Use the function point already properly, assign it to special, run and call. No, not main. I need to execute the program. There has to be. Maybe if I actually read what he's saying. Keep in mind that the architecture of this machine invoke the special function. I wonder if there's a walkthrough for this because I'm just a little stuck. I don't know how to do it. I've heard this running GDB. I'm gonna actually use that. GDB. I don't actually know what to do from here though. GDB. Oh, with debug symbols. There. Reinitialize source path to empty. Oh my goodness, how do I even use this? GDB. I could even put the code here. I did want to see it with Linux though. GDB Linux commands. Start GDB to debug the specified program. Maybe I should have did that first. So exit ls out, quit ls gdb func.pointer. Start. Starting missing separate debug. Use debug. Debug info install glib Amazon 2.x86 64. I didn't think that was gonna work, but start. The program debugging has no. Oh jeez. Execute the next line. Next? Why does this constantly close? How do I make this stay? There we go. Display? The purpose of the debugger is such as to allow you to see what is going on inside of the program executes. Run. Display the value test. Run. I don't know how much that is. Received segmentation fault. And that's the memory location? I wonder if I could find someone here. Overriding function pointers buffer overflow. Maybe I could find a video to watch or just something to help me understand. I'm just gonna, just so I could just get the streak. Okay, let me try this. Quit. Yeah. Python print a times 13. Let's try that. Do I need to? Okay. And then std in, and then what is this thing called? There we go. Great. Now let me try 14. We can see segfault, which confirms that a buffer flow overflow happened. Oh, okay. So segmentation fault means a buffer overflow occurred. So now we have an idea about what's happening here. There's a function pointer that executes a function based on the given memory address of that function. That memory address is stored in a variable, and we can overwrite that variable when we exceed the buffer. How did he get it to list out the memory address? Maybe that's just part of the program? Oh, so once we know, we need to find the memory address of the function that we need to execute. Okay. Okay, so we gotta find the memory address of special. What? GDB-PETA? Break at main. Okay. Then we run the program. We do C to make it continue. Pass our argument. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm gonna put 16 just to see if it tells me 15. And I think that's right. 61, 61. Hexadecimal 8. 61? Nice, it's 61. Okay. So I think we're getting closer. I just need to figure out now what is. I mean, I know where the overflow happens. If we do it will list all the functions and their memory addresses. Wow. That's crazy. Wow. Okay, so I gotta find what's special. Wow. 400567. Wow. Wow. Okay. Um. Notepad. So that's the address. Copy that. So now we gotta figure out. I'm gonna actually use ChatGPT real quick to see if it could just tell me the characters. Can you tell me the character, the hexadecimal? Let's see if it yells at me. It says, "Oh no, we can't do that. You shouldn't be exploiting." Otherwise, I'll just look up. Okay. Alright, let's do this. Hexadecimal chart. This. Oh boy, that's very small. Is this binary? Why am I looking at binary? Oh, wait, no, hexadecimal's included here. Okay, so what do we got here? We got 4. Okay, 1, 2, 1, 2, 1, 2. So 40. Let's find 40. So 40 is. What is the ASCII for it? Oh my god. Is this not the. Okay, I went to the wrong one. Okay, 40, 40, 40, 40, 40. 40 is the at symbol. Huh. At. Now this is going to be backwards. 05, 05. E and Q. Is that even a symbol? E and Q. Okay. 67. G. Okay. Let's try to. Actually, it says it's Endian, so this is backwards. Is this a capital G or lowercase? Lowercase. Okay. Let's try. Let's try it. Okay. Press return to continue. Alright, alright, alright. Okay. Okay, I get it. Wow. Oh my goodness, please. Okay. Let's try it now. I don't know why it would be different. And we got the address. Okay. So I didn't actually need to translate it. Okay, so I'm gonna quit. Yeah. Yes. Oh no, quit. Whoops. Nope, I don't need to quit. What was that command I previously ran? That was Python. Okay, great. So we know 15 is when it breaks, right? Or is it 14? Pretty sure it's 15. This is a legal instruction, but I think it's 15. So 15. I'm gonna do 14. Because I think on 15 it breaks. Print times 14 plus. So I need to do this as endian. So I'm gonna just put that over there. We'll do it backwards. 6, 7. 05. 04. Oh, did I not close it? Why didn't I close it? What did I mess up? Jeez, I messed it up. Close it. And close that. EOL while scanning string literal. I forgot to put the X to identify them as hexadecimal. No, I still did it wrong. EOL while scanning string literal. I put this here. Segmentation fault. Maybe I gotta do 15. No. 13? No. Maybe. Okay, I'm gonna try it this way. I'm gonna try it the opposite way because I typed this in backwards. But okay, so it's 40. Oh, 5. 67. Segmentation fault. Now let me actually try the characters because maybe that's all it is. Maybe I gotta put the characters instead. So I had at plus e no e and q plus g. Now I'm gonna be honest. I'm surprised that I would have to do that. I have to be getting closer. E and q plus at segmentation fault. Calling. We see the function when is defined at the top, and after it defines the function pointer. Okay, maybe I grabbed the wrong address. Object dump D. Now what is stack 3? Stack 3? Oh, this is what he called his file? So mine's actually func pointer. Okay. Now that's main other special. 0567. Interesting. So I definitely have it. 40. We got the address. Now we can easily build the exploit. So maybe 15. No, you know what? Let me go back to the original 40. I think it's backwards though. I'm gonna try 15. Now I'm gonna try 16. How do I test? How do I test this? To see what the address is. If I do GDB, excuse me. And then run exit. I need to select the file. Oh, use file. Funct. Run. See. What is it? What do you say? Break on main. Run. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then X 40 05 67. Oh, did I not? I thought I ran this. Oh, C maybe? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 40, 05, 67. I'm so close. I just don't know what. Let me buffer overflow. How does this not have a walkthrough? Nope, that's pointers. Is this it? This is very difficult. Is this what I'm looking for? Chat's buffer flow. Geetra. Info. Registers? I don't know what the point of this stuff is. Find the offset to overwrite EIP with your controlled address. Python C print. Maybe I'm not typing this right. Plus, I'm just gonna try this just to see what happens. And I typed it wrong. I'll get it sooner or later here. This is crazy. Let me actually go to the next one. Just see if it describes it. Let's look at buffer overflow 3. What is this? Oh, I think this is it. I don't know what buffer overflow prep is. Maybe this is actually OSCP related. I guess maybe that should be a goal, is to get OSCP. This isn't really helping. I feel like I'm so close. I just don't know what I'm missing. Print then crazy. Let me just do this room, see what I can find. For this example, look at overflow 3 inside. You'll find the following C code. What is this? Why am I not in the right? How about not SSH anymore? What's the 10.201? Alright, so CD overflow -3 ls nano. Oh, what is a secret.txt? Okay, so I'm using buffer overflow to reveal the secret. Buffer overflow.c. Here's a program that echoes out your input. Okay. Oops. Buffer. Am I supposed to type? Okay, I'm supposed to type. And obviously there's a huge... I think I could probably just run Python on this. A times... I don't know. What did it say? 120? Oh, 140. 140. And then we do this. Buffer. I totally may have just typed that wrong. Let me type this. It's not going to help me. I can't believe it helped me. Why didn't that work though? Unless it faults a lot earlier than I thought. There's no way it could fault that early. 10? 1? What did I type wrong here? Let me pull that up. Print A times 1. Then buffer overflow. I'm gonna just try it like this. See what it says. 50. And then we're gonna execute buffer overflow. Lost sister. I don't know what sister is. Okay, let's just do this. Buffer overflow. And in theory, this should be like 120 characters. Okay, it's segmentation folded. Alright, well, we found exactly where any text after this would trigger the buffer overflow. So I'm just going to copy that. It's probably... Whoops. 143. Okay, it's 143. So... It also follows that we can overflow the return address with our own value. We can control where the function returns and change the flow of execution. For now, is the shell code that opens up a basic shell. We'll use a shell code. So why don't we... Okay, I didn't know what that was for. Is it trying to help me? Oh boy, that's confusing. I didn't actually want it to execute though. So let's do this. Python -c print x90 times 143 plus, what in the world? So this is the shell code? Why is it so broken up? Plus x41 x41 times 60. Why? Oh goodness, this got so confusing. I wonder if I should have just copied it just how it was listed. And then, I don't even know what the program's called. Where am I missing the, did I forget the, one more of these? Oh my goodness. Syntax error. Did I not close it? Aren't I looking at the close right here? I feel like I'm looking at the close, isn't it? Near syntax error near unexpected token. What? I also forgot to, maybe I gotta put this instead of what I did before. Do I not close this? I don't understand why I don't, what am I missing? Is one of these not? I'm Jesus. All right. All right. We're kind of drawing a bit long here, but I'll be working on this pretty much all night. So take care, guys. See you tomorrow.